Welcome back to Algebra 2 Lesson 3.7. This is video 2. If you haven't watched video 1, you should go watch video 1. Okay, we've seen an application of a 3 by 3 determinant and finding the area of a triangle. Let's look at an application of 2 by 2 determinants. It's called Cramer's rule, and it's a way to solve a 2 by 2 system. We've already talked about solving these systems by graphing and by substitution and by elimination, so this gives us a fourth method. We're going to let A be the coefficient matrix of the linear system AX plus BY equals E, CX plus DY equals F. So that means the coefficients are A, B, C, D. So A is a 2 by 2 matrix. The first row is just AB. The second row is CD. If the determinant of A is not equal to 0, then this system has exactly one solution. So part of why the determinant is called the determinant is because it determines whether or not a system has a solution. It also determines whether or how we determine a 2 by 2 matrix has an inverse. So the determinant of A helps us determine whether or not there's a solution to a linear system like what we have here, and it also helps us determine whether or not a particular 2 by 2 matrix has something called an inverse, which is what we'll talk about next class. Okay, so it has exactly one solution, and it is equal to the determinant of EF BD, there, EF in the first column, BD in the second column, over the determinant of A. And notice that E and F are the constants there, what the equations equal, and it's like they're replacing AC. They're replacing the coefficients of X. And then BD stays in its same place of what would be the coefficient matrix. And then Y is the first column AC, second column EF. So again, on this one, you keep the coefficients for the x's, but then the coefficients for y's are replaced with EF, which is helpful if you have to memorize it. You're not having to memorize it, so it'll be on your formula sheet, but I just thought I'd point that out. All right, let's look at an example. We're going to use Cramer's rule to solve this system. We've got 9x plus 4y equals negative 6. 3x minus 5y equals negative 21. So our matrix A is going to be the 2 by 2 matrix 9, 4, 3, negative 5. It's just a collection of our matrices. And so we want to find the determinant of that coefficient matrix. So again, matrix A is 9, 4, 3, negative 5. The determinant, which would then just have the little lines there. Again, it's a little typo with these pre-made PowerPoints, and I can't fix that. But actually, for finding the determinant of this, we should then just have the lines surrounding the 9, 4, 3, negative 5. You do A times B, so negative 45, because 9 times negative 5 is negative 45, minus C times D, so minus 3 times 4. So it's the major diagonal minus the product of the minor diagonal, and that's negative 57. So that's going to be our denominator for our x and our y. So Cramer's rule can be applied because the determinant is not 0, so we determine that we can continue. Okay, so for Cramer's rule, you're going to find the determinant of the matrix where you've got EF in the first column, so negative 6, negative 21, because those are our constants. And then the coefficients of the y remain in there, so 4, negative 5. So let's do that. Negative 6 times negative 5 is 30, minus negative 21 times 4 is negative 84. So 30 plus 84 is 114 over negative 57, and that divides out to be negative 2. So we know x is negative 2. Now let's do y. So for y, we're still going to divide by the determinant of A. So we still divide by negative 57. We use our coefficients for x in the first column. Okay, we use AC there, so we've got 9, 3. And then we put EF in the second column, our constants, so negative 6, negative 21, and then we do the determinant. 9 times negative 21 is negative 189, minus 3 times negative 6 is negative 18, Negative 189 minus minus negative 18 is the same thing as negative 189 plus 18. And that gives us negative 171 divided by negative 57, and that gives us 3. The solution then is negative 2, 3. Okay, if we want to check it, we check it just like you do whenever you solve by graphing or solve by substitution or solve by elimination. You just plug both the x value and the y value back into the original equations. So 9x plus 4y equals negative 6. We plug in negative 2 for x, 3 for y. 9 times negative 2 is negative 18. 4 times 3 is 12. You add those together and you do get negative 6. Now we need to try it in the other equation. 3x minus 5y equals negative 21. So we're going to have 3 times negative 2 minus 5 times 3. And we're going to see if that equals negative 21. So negative 6 minus 15 does equal negative 21. So it works. The negative 3 works in both equations, so it is our solution. All right, that's the last example we're going to do. You've got some problems to try on your own there. Go ahead and do that and come to class ready to check those and to start your rounds. Now remember, the formulas from today are going to be provided for you on the test, so you just need to worry about being able to apply them. Okay guys, I'll see y'all later. Y'all have a good day, and I will see you in class.